Ma'am, I've sent the question.
Okay, Abdullah, I'll just check. So, Abdullah, I'll help you with this question. Just tell me one thing. Uh, do you wish to stay also after this doubt? Otherwise, I'll read it out at the end. Or you just have this doubt only?
Ma'am, at the end you can just explain this.
Okay, you're there in the class today?
Yes, ma'am.
Okay. So, at the end of the class,
Okay.
Okay, before, just let me end this topic, optical instruments. In the previous class, we were discussing ray optics. We had started with ray optics, and most of the portion of ray optics we have already covered. So today's class, we'll discuss optical instruments. This was left in the previous class. So as already discussed, optical instruments are the devices which make the use of mirrors, lenses, and prisms and are primarily used to exchange the range of vision. So mainly you have three kinds of optical instruments. Here the human eye also acts as an optical instrument. Microscope acts as an optical instrument, and telescope. So human eye you don't have to do. Microscope you have both the cases. You have simple kind of microscope and compound microscope. So in simple microscope and in every other microscope, you mainly basically have two cases. Two cases where you have final distance at final image at infinity, or the final image is formed at least distance of distinct vision. So least distance of distinct vision, this basically means when you are able to observe or see the image very clearly. So least distance of distinct vision for human eye is how much?
25 centimeters.
25 centimeters. This is 25 centimeters. So at a distance of 25 centimeters, we all are able to observe images. We are able to clearly see those images. Now see, in case of simple microscope, compound microscope, both of them, you have the cases of least distance of distinct vision and when the image is formed at infinity. So let us just talk about simple microscope first. So before doing the revision of derivation, remember, in the both of the cases, when the image is formed at 25 centimeter, in short, if you have to remember, then the magnification becomes 1 plus capital D by F, where capital D is the least distance of distinct vision and F is the focal length. If the image is formed at infinity, your final answer, just eliminate this one. Remember only D by F. Forget rest of the term. So these are the two cases in simple microscope, the formulas which you have to remember. Just in case if the derivation comes for it, then see, for least distance of distinct vision, first, without the lens, draw your eyes. Whatever your eyes are able to see. If this is the object, then this will be the vision, this will be the light rays that will be falling on it. So we call this alpha. Alpha is the angular magnification that is subtended by the eye without the lens kept. Now see, if you put up the lens, what will happen? Lens will refract it. So instead of going straight the way it was going, light rays will now bend to some other distance. This other distance will lead to the creation of different image that will lead to magnification of the image. And this image that we get is magnified and enlarged form. So see, if this is alpha, we call this angle as alpha. this is beta, this angle that we have taken. This is a straight line. This, it has to be a straight line. Now see, if you see tan beta from this, if you take up tan beta, this is what? This is AB divided by BO. Now see, here our object was kept. So this is U, that is image distance. Then image is now finally forming here where the light rays got enlarged. So this distance, that is 25 centimeter, which we are able to observe clearly the image. This becomes our image distance. All right, so tan beta will be what? AB divided by OB. So AB is the height of the object divided by the height, divided by the distance of the object, means object distance. And magnification is what? Magnification is beta divided by alpha. This is magnification. So it is the ratio of angles subtended by image and object on eye when both image and object are at least distance of distinct vision. From here you can see, here the object is kept at least distance of distinct vision. Here the object is kept at 25 centimeters. So this angle becomes alpha. Now in this case, the image we are able to see because of the lens at 25 centimeter. So this image distance now becomes 25 centimeter. So we call this as beta. So ratio of alpha and ratio of beta, means beta divided by alpha basically gives us the magnification. From here in one more thing, if you take tan theta of both of them, so you have tan alpha with you have tan beta with you, and you know tan theta is almost equal to theta from small angle approximation. From small angle approximation, where sine theta and tan theta both can be equal to theta. So M is what? Magnification is AB divided by OB, means the ratio of tan beta and tan alpha. That gives finally D by U. Now see, U can be eliminated using this formula, the lens formula that you have. Lens formula says what? 1 by F is equal to 1 by V minus 1 by U. This is a lens formula. So using lens formula, if you keep all the values and find the value is of 1 by U, you finally get the answer as 1 plus D by F. So this is the case for least distance of distinct vision. If the final image is formed at infinity, now see what the difference will come. Instead of forming the image at least distance of distinct vision, we have the image formed at infinity. Object distance will remain same, alpha will remain same over here. What will alpha be? See, if this is the lens, our final image is forming at now infinity. Initially, we had kept this at 25 centimeter, but now we are talking about the case for infinity. And what about the first case? If human eyes are kept in this manner, object is there. So there is no object or there is no instrument to deviate them, deviate the light rays from the object. Since there are no refractive substance or objects to refract these rays of light, then we get this as alpha. So angle subtended by the alpha. Now see, again you go through the same procedure, just the difference that will come, instead of taking U, we can take U is equal to F. Why? See, when the image is formed at infinity or the light rays are coming from parallel, where will they converge? They will converge at the focus. So this becomes your focus only. So this difference will come, then rest of the manner is same. You finally get M is equal to D by F. Same method. You take out tan alpha, you take out tan beta, take the ratio of them. That will lead you towards M is equal to D by F. From the formula, this M is equal to beta by alpha. So M will be equal to tan beta by tan alpha. And as I've told you, tan beta or tan alpha both can be written as beta by alpha because tan theta is almost equal to theta. So this is how you finally get the derivation. Now see, then you have the case, or let's discuss all the cases first and we'll do questions. Or let's do a question on this one. Let's do a question on simple microscope first. So all of you try this question which I'm giving and send me the answers in the chat box. Whoever gets the answer, just send me the answer in the chat box. Use the concept of combination of power and combination of focal length. Yes, Abdullah, your answer is correct. Rest of you also submit your answers. Firstly, apply power combination of power. How do you get the final power? Then if you have the final power, you can get the focal length of the combination. And when you have the focal length, you can get the magnification power. Correct. Shehzada, your answer is also right. Just take 1 more minute, 1 or 2 minutes, and rest of you also submit your answers. Amalia, Mariam, Afan. See, there are two powers given to you. First power, P1 is what? 15 diopter. P2 is 5 diopter. So if you take the combination of powers, when you have various powers with you and number of powers are there, then resultant power is given through the sum of individual powers. P1, P2, P3 up to whatever Pn is given. So since we have only two powers, so power net will be equal to what? Net power will be equal to 15 plus 5, that is plus 20 diopters. Focal length is the reciprocal of power. So focal length will be what? 1 by power. If power is 20, focal length will be what? 1 by 20. That gives 5 centimeters. This gives 5 centimeters. Now see, you have F with you. F is 5 centimeters. You have D with you. D is what? 25 centimeters. You have to find out magnification. And this is which case? Final image is formed at 25 centimeter from the eye. It means image is formed at least distance of distinct vision. So M is what? M is equal to 1 plus capital D by small f. This is 1 by 25 by 5 is equal to, this is 5, 5 plus 1, 6. So just note it down, those who haven't. Then we'll do one more question on this. No, Shehzada. See, 25 centimeter is the least distance of distinct vision. No. So V will be equal to minus 25 centimeter. You have to find out U. Where should
Yes,
the
yes.
object be placed?
Yes.
Yes, Abdullah's answer is that. Okay, so let's discuss it once. See, an object is to be seen through a simple microscope of power 10 diopters. Now see, what does the question say? It says where should the object be placed? So you have to calculate the object distance. This is U is unknown to you. You have to find out U. What is given to you? Power is given to you 10 diopters. Image distance. See, where should the object be placed so as to produce maximum angular magnification? This means you have to find out object distance simply. Now see, least distance of distinct vision, that is V. This is minus 25 centimeters. Why? Because of least distance of distinct vision. Least distance of distinct vision. All right. Now see what one quantity is missing in order to relate image distance and object distance. Focal length is missing. And see, power is given. So you can easily calculate focal length by 1 by P. That will be 1 by 10. This will be 1 by 10 meters. So that will become 10 centimeters. This will become 10 centimeters. So you have focal length now, you have the image distance now. See, 1 by U will be equal to what? 1 by V minus 1 by F. So minus 1 by 25 because V is minus 25 centimeters minus 1 by 10. This becomes minus 7 by 50. So V will be what? V will be minus 50, not V, U. U will be minus 50 divided by 7. So U will be minus 7.1 centimeters. So just note this part as well. See, Amalia, in case of image that is formed over here, image is formed in front of the lens only. No, if you remember the derivation, this is the derivation. This was the derivation. So image is formed in front of the lens. And whenever you go opposite to the direction of rays of light, your sign convention is taken as negative. That's why we always take object distance as negative. And now image is kept along with where the object distance is kept. So image also becomes negative. Fine?
Yes, ma'am.
So yes, written or is anybody writing? Yes, completed?
Yes, ma'am.
All right. So let's discuss the other microscope that we have, compound microscope. Now see, compound microscope is an optical device used to see magnified images of tiny objects. As it is written here that it can magnify 1,000 times. So a good quality compound microscope can produce magnification of the order of 1,000. Now in the construction of compound microscope, it consists of two things. One is the object lens, other one is the eye lens. So object lens or objective lens, it is positioned near the object to be magnified, and eye lens it is positioned near the eye to view the image. Now see, again you will be having two cases as well in case of compound microscope. So compound microscope also, before going into the derivations revision, let We write the formula in short. So see, for compound microscope, if the image is formed at 25 centimeter, means least distance of distinct vision, then your magnification is V naught divided by U naught 1 plus capital D by FE, which can also be written as minus L by F naught 1 plus D by FE. These are the two formula that you have to remember whenever you are revising optical instruments. And if image is formed at infinity, then you get final magnification as V naught by U naught, instead of, again, whenever you have infinity, eliminate the one. What is left? D by F. This will be, which can be written as minus L D by F naught F. So these are the two formula that you have to remember. Now see, for compound microscope, first case, just draw the eye lens near the eye, objective lens far away. Keep the object away from the objective lens. Now the rays will follow and form up the primary image. This will be the first image that will be formed. So this is the simple part that you already know, how a single lens is kept, object is kept, and the light rays form the image. Now see what will happen in this case. Light rays will not stop here. Why? Because we have another large lens kept. So what will happen? All the light rays that are coming from the eye, these will see, if your eye is kept, all the rays that will be put into the eye because of this image, those will form another magnified image, which we are able to observe and which we are able to see. So this derivation includes this basically. Now again, remember where you have to take alpha, where you have to take beta. Since your angle, now your final image is over here, so your this angle will become the angle which is over here, means this is beta now. Beta is what? Angle subtended when the lens is kept, and this is when you don't have the lens. So again, m will be equal to beta divided by alpha. From all the diagrams, you just take the ratio of tan alpha by tan beta, divide them, you get the answer in terms of m is equal to HID divided by UE H naught. So this is also one of the formula that you can remember if you are given height of image, height of object, and image object distance of the eyepiece. If such data are provided to you, then you can use this formula directly. If not, then you can use this final formula that we have discussed, minus V naught by U naught is multiplied by 1 plus D by F. Now see, if the final image is formed at infinity, nothing changes except for the fact that the final image is at infinity. This image was initially forming over here at 25 centimeter from it. Least distance of distinct vision means this whole distance was 25 centimeter. Now the final image is formed at infinity. So this, again, UE will be equal to FE. UE means object image, object distance of the eyepiece, and the focal length of eyepiece both become same. So if you look at the derivation, you have to similarly do it, and then your final magnification will come out to be minus V naught by U naught D by F. All right, let's practice questions. Yes, the correct answer is given by Shahzada. Right. So see, it says you are given two converging lenses of focal length. Okay, so two different focal lengths are given to you. It means FO means focal length of the objective. This is given as 1.25 centimeters, and F 5 centimeters will be what now? 5 centimeters will be FE, focal length of the eyepiece. Least distance of distinct vision will always remain the same, 25 centimeters, while the magnification is provided to you as 30. So magnification is M is 30. See, if you are able to recall this formula, only one thing is missing. L is missing. L is what? L in the formula that we did, M is equal to L divided by F naught. 1 plus capital D divided by FE. In this formula, if you remember, L is what? L was the separation between the objective lens and the eyepiece. If your objective lens is over here, eyepiece is kept over here, this separation. This is the length of the tube. We call this as the length of the tube. So this is L. So see, rest of the things are given to you only. This L was unknown. The rest of the things are already given to you. So it's just linear equation question. M is what? M is 30, L is unknown, F naught is 1.25. And in case of microscopes, you don't have to put sign convention, as I've told you already. 1 plus D is 25, FE is 5. So this becomes 5 into 5, this becomes 6. So L will be what? 30 multiplied by 1.25 divided by the 6. So length will come, as rightly said by Shahzada, this is 6.25 centimeters. So all those who have not written, just note this down. Written? Now see the revision of the formulas of the telescope. Let's do the revision of the formulas of the telescope. Now see, in case of telescope, you have astronomical telescope. In normal adjustment for astronomical telescope, you have astronomical telescope with you. Now, first in the normal adjustment, in normal adjustment, M means your magnification is focal length of objective lens divided by focal length of eyepiece. And also if you have to calculate the distance between objective lens and eyepiece, distance between objective lens and eyepiece, this is equal to f naught plus fp. So in questions, if you are given this hint, you can use the data using f naught plus f. You can take this. Now see, if your final image is formed at least distance of distinct vision, means d at 525 centimeter. This is your image, this image formed at least distance of distinct vision. Then your final m is equal to f naught divided by fe, 1 plus fe by capital D, and then distance between objective and eyepiece. This distance between objective and eyepiece, this becomes UE, means image distance of eyepiece plus focal length of objective, which can also be written as f naught plus FED divided by FE plus capital A. This is for the astronomical telescope. Now see, if you get by chance terrestrial telescope, then in normal adjustment, m is equal to f naught by fe, similar, but the difference will come in the distance between objective lens and eyepiece. Distance between objective lens and eyepiece. This will be now f naught plus 4f plus fe. So where this f, this normal f, this is focal length of the erecting lens. Focal length of the erecting lens. Then you have reflecting telescopes as well. You have Galileo's telescopes as well. Let's do a question. Before that, just note down these points on telescope. Then we'll do a question on this. Yes, you have to make two questions, Shahzada. See, I'll help you with this. So, yes, Abdullah, your answer is correct. So, only Abdullah has given the correct answer. Now, see, magnification is equal to what? Magnification is F naught divided by Fe. Now, what is this 100? This is magnifying power, means magnification is given to you as 100. So, 100 is equal to F naught divided by Fe. You can establish a relationship between them, means F naught is what? F naught is 100 times Fe. Now F naught is 100 times Fe, and you know focal length of objective and eyepiece. I've just told you distance between objective and eyepiece is 101 centimeters. Means F naught plus Fe. This is the distance between objective and eye lens. This is 101. Put the value of F naught from this. This will be 100 Fe plus Fe gives 101, means 101 Fe is equal to 101. So Fe will be what? Fe will be 1 centimeters. Now put this in the other equation that you have. In this, F naught will be equal to what? 101 minus Fe. This will be 100. This will be 101 minus Fe, means 1. That is F naught will be equal to 100 centimeters. So Fe will be 1 centimeter, F naught will be equal to 100 centimeters.
Ma'am,
Yes, Abdullah.
ma'am, will we consider magnification as negative or positive?
Magnification, you don't have to take any sign convention in this. All these formulas. Whenever you are considering optical instruments, all the formula that we have used or we are using, these are already sign convention driven when we have derived it. So you don't have to take the negative sign. Here in this case, means in optical instruments cases. Otherwise, when you do your magnification questions generally for lens, apart from optical instruments, there you have to consider magnification. Or even sometimes questions are also asked, if magnification is -3, what is the nature of image? And so there you have to consider, but not in case of optical instrument. Fine.
Yes, ma'am.
Done. Yes. Amalia, Mariam, Shehzada.
Yes, done.
So see, ray optics is over. This was a quick revision of ray optics. Let us start the revision of atoms. Now see, let us start with its revision. So in atoms, mainly you know all the theory part, Bohr's theory. Now see, let us quickly revise all the formula that we have in under the heading of Bohr's theory of hydrogen atom. So Bohr's postulate you should know. So Bohr's theory of hydrogen atom. All right, of hydrogen atom. So see, one you have to remember is kZe square by R square. This is equal to centripetal force, mv square by R. This gets used. You have to remember L is equal to mvr, which is equal to nh divided by 2 pi from your quantization and angular momentum. Then h nu is equal to energy of the final shell minus energy of the initial shell, n2 minus n1. Also, you have fourth number, you have to remember that radius of any n orbital, this is given by n square h square divided by 4 pi square mkz e square. Regarding the velocity, Cn, this is given by 2 pi k e square divided by ch or nh. You can take it as nh or ch, or let me write nh only. 2 pi k e square divided by nh. This is the velocity. Then your easy formula for kinetic energy, you have kze square divided by 2r. Now see, regarding kinetic energy, total energy and potential energy, you have to keep all the formulas in mind because all are connected. Then kinetic energy, so potential energy, just eliminate this r and put a negative sign, means minus kze square divided by r. Just eliminate this 2 and add a negative sign. In case of total energy, put the minus sign into this kinetic energy. Means that will be total energy will be what? Total energy which is equal to minus of kinetic energy. Or you have to remember other formula of kinetic energy as well. The total energy. Total energy, this can also be given as this, the long formula that it has 2 pi square mk square z square e to the power 4 divided by n square h square. So now see, we don't usually use this. We usually use minus 13.6 divided by n square electron volt. Then energy is basically, you have to remember that twice of kinetic energy, or you can simply say potential energy, the relationship between energy. This can be written as the relationship between energy, kinetic energy and potential energy, so as to ease your calculation. So potential energy is what? Minus 2 times kinetic energy. So if you are given kinetic energy, no need to calculate, just double it and add a negative sign. Also, if you have to calculate wave number means what? 1 divided by lambda. So you can use it by using Rydberg's constant. So R will be equal to 1 by n1 square minus 1 by n2 square. This is R. So where this R is the Rydberg's constant. Rydberg's constant. Also, one more thing. 9, 10, 11. The ionization potential. This is equal to minus 13.6 Z square divided by N square volt. SI unit will be volt. And if you have to find out the time period, this also comes. Time period for any n number of rotation. This is equal to 2 pi r to the power n means any orbit or v to the power n. So n can be any number, 1, 2, 3, 4 up to infinity. All right, so just quickly note down these formula. One more thing regarding the constants, you have to remember at least 3 constants that might not be available to you in the question. So the constants that you should remember, the value of the constants. So some constants used you should remember is first is your Rydberg's constant, whose value is 1.097 into 10 to the power 7 per meter. Other constant which you should use or know is 6.63 into 10 to the power minus 34 joules second. This is your Planck's constant. And the final, which you should remember, is mass of an electron, which is 9.1 into 10 to the power minus 31 kg. All right, so quickly note down these formulas.
Ma'am, which chapter we are starting next?
This is atoms from your modern physics.
Yes, ma'am, next chapter. Name of next chapter we will start.
Next chapter, firstly, tomorrow we'll do some questions on atoms, since today we are only discussing the formula. Then your next chapter will be nuclei and dual nature, the questions on, we'll be just focusing on modern physics right now. Let's complete that. So tomorrow we'll be doing some numericals on atoms and nuclei will start. So all those who are done can leave except for Abdullah. Abdullah, you just stay.
Ma'am, what is 7 number formula? Ma'am? It's not showing clearly.
Which one?
7, 7. 7, 8.
7, 8. Is this visible now?
Yes, ma'am. 12. Done, ma'am.
Okay, so who all are done, you can leave the meeting. Only Abdullah used to.
Ma'am, last. Please.
Last one means, okay, this constant all.
Yes, ma'am.
Yes, Abdullah. See, the question says what? It has given, it says a asymmetric biconvex lens of radius of curvature r, and it is made up of glass of refractive index 1.5. This is placed on a layer of liquid placed on top of a plane mirror as shown in figure. An optical needle with its tip on the principal axis of the lens is moved along the axis until its real inverted image coincides with the needle itself. The distance of the needle from the lens is measured to be x, and on removing this liquid layer which is placed, you have to repeat the experiment. So when you repeat the experiment, that is found to be y. So x was initially, then you have it as y. So you have to obtain expression of refractive index in terms of x and y, both of them. Now see, refractive index given is to you of what? The material is glass, so this will be 1.5. Now see, the distance of the needle from the lens in the first case, that will be equal to the focal length of the combination of the, now you have to understand what will the combination be. So it will be a convex lens and a plano concave lens which will be formed by the liquid. See, if this is your lens, this is what? This is convex lens. This is convex lens. Now see, if you put a liquid, if you put this on a surface in this manner, and you put a liquid within. So observe this, along with this whole combination, if you see, this is a convex lens. This part that is formed, this acts as a plano concave lens. Plano concave lens is what? This is your concave lens. If you split half it, take the half part of it, the half part of it becomes plano convex lens. So this is your plano concave lens. So your image is, your focal length is a combination of what? Focal length of the combination of the convex lens and plano convex lens formed by the liquid, that is given to you as x. So f is equal to x in this case. Yes.
Ma'am, it's plano convex or plano concave?
Sorry, plano concave, not convex lens and plano concave. Convex lens and plano concave. Then distance measured in the second case. This is given to you as y. So let's say f1, this is y. Now see, the focal length of plano-concave lens formed by the liquid means the focal length of this only, plano-concave lens. This is f2. Now you have x, y, f2. So when you have various focal lengths with you, what do you calculate? F1 by f1 is equal to 1 by f is equal to 1 by f1 plus 1 by f2 and so on. This is how you take the combination of focal length. So now just put it over here. Find the value of f2. So see, directly if you subtract, if this will go over here, 1 by f will come over here. And instead of f, write x and y. So this will be what? Denominators will get multiplied, means f will get multiplied with f1, that is xy. And then both of them will be subtracted, means f1 minus f5 will be y minus x. This is the value of f2 you have. Now see, in refractive index of the lens is what? Refractive or index of the lens is 1.5, that is given to you. Now see, radius of curvature of one surface is r, and the radius of curvature of the other substance. Radius of curvature of one substance is r, and the radius of curvature of the other substance becomes minus r. This we have done in the derivation of lens maker formula as well. Now see, if you put the value of 1 by f1, this is what? Mu g minus 1 by r minus 1 by r. So this becomes 1 by r plus 1 by r. So in short, you can write mu g minus 1 2 divided by r, means 2 by r. This part will be 2 by r. So see, this is what? 1 by 1 is what? This is 1 by y. So if you put 1.5 for mu g as glass, means refractive index of glass is what? 1.5. 1.5 minus 0.5 is half. So 2 will get cancelled and radius of curvature will be equal to y. All right. Now see, if refractive index of liquid is, let's say, some mu1, which we are establishing the relationship with. So if it is mu1, then see, radius of curvature on the other side of the plane mirror, because this is acting now as a plane mirror. So what is the radius of curvature of a plane mirror, Abdullah?
Ma'am, infinite?
Infinite. So radius of curvature on the plane side. On the plane side will be infinite, whereas the radius of curvature for the side of the lens, means lens side, this will be equal to capital R. Now see, y minus x divided by xy. This gives mu1 minus 1. Just put everything in the lens maker formula. 1 by minus r1 minus 1 by infinity. So 1 by infinity is 0. So this will be mu1 minus 1 is multiplied by minus 1 by y. Why I have written y? Because r was equal to y, which we concluded. Now see. Yes, say.
How we got y minus x by x? Y? It's reversed, right? xy by y minus x. F2.
1 by f2 you are taking, no? Lens maker formula.
Oh, okay.
Okay, 1 by f2 you are taking. So now see, now you have mu1 minus 1. This is equal to what? Just multiply the y over here, or you can simply take negative of y minus x by x. Now you can solve. Now you already have a relation. See, mu1 minus 1 multiplied by minus 1 by y is equal to what? Y minus x by xy. So just simplify it. Now you have a relationship between, just take rest of the terms over here and find out what is mu1 in terms of x.